adapt, move, or perish. These are the three ways we have seen ancient societies respond to climate changes. Today, the students of the University of Greifswald will take you on a tour through time and across continents to explore how human societies have been affected by climate change. From the Neanderthals and the Indus civilizations to the Norse and Greenland, you will hear intriguing stories about the fates of the societies. In the end, we will discuss the present and future and how this relates to us today. But first, let us introduce you to a few theoretical concepts that will often pop up throughout the whole conference.
This is Amelie and Samuel. We have prepared this poster for you to set the tone for this conference. We would like to briefly introduce you to the topic of societal changes and their connection to climate change. Our main point of interest are ancient societies from all around the world and their reaction to changing climate.
As we are landscape ecologists, we are not often dealing with research on human societies, and the topic was a bit challenging. But we got an insight in the topic first by the book Collapse by Jared Diamond, and took his model of the influencing parameters for societies. But as there's a lot of valid criticism on his book, we mainly applied then the Questioning Collapse book, which is kind of an answer from a lot of other scientifics and was published some years after his book, and we took some lessons from it on how to assess early and also today's human societies.
In the central part of the poster, you can see a model with different factors that are influencing societies.
So, how to assess ancient societies? A growing awareness of history and one's own perspective is necessary for the representation of ancient societies in science but also in the popular media. Western research has its origins in the colonial era and was involved in the exploitation of many peoples and cultures. The global measurement of climate parameters, for example, began around 200 years ago when colonial states set up weather stations in their growing territories. They justified the colonization and devaluation of foreign societies with the mistaken belief that climatic conditions determined also human characteristics. So when we evaluate ancient societies today, we should do so in a respectful and as objective as possible manner, and not with labels like failed or successful societies. We need to question how we portray both the people of past societies and those living in the succession of empires today, because the world today is also a product of past societies. We can question to what extent are the climate and the environmental problems of today comparable to those of history, and can we even learn from past societies and their developments?
To assess the impact of the climate change on societies, we need to first reconstruct past climate. To do that, scientists use proxy data such as tree rings or fossils. They analyze, for example, growth rates or pollen assemblages. They can also use human documents like cookbooks for additional clues. With climate reconstruction, we have to stay mindful of the possible biases, for example, in the distribution of proxy data.
So obviously climate can't be the only driver in the society, but as we are a climate conference, we have a focus on that and want to introduce you an interesting new approach. It's the HCS, the History of Climate and Society, and this is an approach to unite all the different disciplines working on this wide topic under one term. So archaeology, history, economy and other humanities, as well as natural sciences like genetics or climatology. And the idea is that it's easier to investigate cause-effect relations between climate and human activities, or, for example, to model as well the past and the future conditions our societies were or will be facing. And therefore HCS studies could also be a good tool to inform policy and activism and help us to get through this climate crisis we are facing.
For our first case study, we'll listen to an interview shedding light on the drivers behind the replacement of Neanderthals by modern humans. It has long been assumed that climate change played a significant role in it. But was this true everywhere? Were there other factors at play? Stay tuned to learn more.
Welcome to the Climate Change Podcast. Today we will talk about the role of climate change in the replacement of Neanderthals by modern humans. Was it just because of climate change, or were there other factors at play? To shed light on this, we have Paula Sanchez, master's student at the University of Greifswald. Welcome, Paula.
Hi, thank you for having me.
Let's start with some more background. Neanderthals lived in Eurasia during the last glacial period, which was marked by significant climatic instability. Around 40,000 years ago, Neanderthals were replaced by modern humans. Could you elaborate more on this replacement process?
Certainly. So we have to imagine this process or this replacement as a complex and diachronous process, meaning it didn't happen uniformly across all regions. Climate change has often been suggested as a primary driver, but this was just in certain regions and overall was not the only factor.
During the last glacial period, we experienced rapid climatic fluctuation known as Darmstadt-Oeschger events. Can you explain what are these and how these events impacted Neanderthal populations?
These events, as you said, were fast cyclic climatic changes, meaning we would have a very fast rise in temperatures, maybe around 10 degrees, in the time span of 10, 20 years, followed by centennial cooling down, and then a period of stable cool temperatures, which caused, of course, kind of very cold and airy conditions in Europe. This led to the retreat of woodlands and the expansion of steppe habitats, changing all the available resources for Neanderthals, which make them depopulate their habitat range. And then when the conditions would get better, the climate would get warmer, we would then see a repopulation by modern humans who were better adapted, and therefore Neanderthals had worse or less chances to repopulate these habitats. So we have to imagine this process over different cycles, climatic cycles in whole Europe in different times.
So that would be the theoretical scenario. But what evidence is there to prove that climate change led to the replacement process?
So for two of these cold periods, around 44,000 and 40,000 years ago, we have a very accurate paleoclimatic reconstruction for certain regions in Europe. And then in those regions, in those sites, we can check the archaeological successions to test for this scenario. Do we observe a replacement on the technology? Do we observe that during the cold periods there's no technology at all and then just modern humans? So that's how we could test this scenario.
Could you give us some examples to make a better understanding of this?
Yeah, sure. So, for example, in Central Europe, we observe that 44,000 years ago, Neanderthal technology disappears, followed by a layer with no technology. And then after the cold period, we see the appearance of modern human technology. Therefore, then we see that climate was a starter for this replacement process. In North Italy, on the other hand, we see a change on the technology, meaning that populations adapted kind of to climate change. And in Western Europe, on the other side, we have this disappearance during this cold period, but 40,000 years ago, so a little bit later. So then we see the difference in regionality.
All right. So this means, as you mentioned before, that climate change was an important starter in some regions, but not in all of them. What other factors played a role in Neanderthals' replacement?
Recent models have shown that demographics had a big influence on their decline, Neanderthal decline. Like they had really small populations that were genetically isolated, making them more vulnerable to genetic drift and inbreeding. And additionally, we have this competitive exclusion by modern humans. They were more generalists and could use the scarce resources better, and also a kind of assimilation of the populations.
Okay, so in summary, the replacement of Neanderthals by modern humans was driven by multiple factors, with climate change being a significant but regionally variable one. Thank you, Paula, for providing these insights.
It was my pleasure. Thank you for having me.
And thank you, listeners, for tuning in.
The next topic is about the ancient Indus civilization, which flourished from 2600 to 1900 BC in the continent Asia. We will try to uncover various causes of their movement through scientific literature.
Hello everyone. When we are talking about the ancient civilization, it is unfair not to talk about the Indus civilization, as this civilization was one of the most widespread of the three earlier civilizations of the ancient world, along with the ancient Egypt and Mesopotamia. Indus civilization had two great cities, Harappa and Mohenjo-daro, and they emerged around 2600 BCE along the Indus River Valley in the Sindh and Punjab provinces of Pakistan. Their discovery and excavation in the 19th and 20th centuries provided important archaeological data about this civilization.
The reason why we chose the mature Harappan phase is because in this phase the Indus civilization was in its golden age. This era witnessed establishment of several settlements, immense growth in agriculture, trade and architecture. There were two distinct climatic periods in the mature Harappan phase. In the earlier half, the climate was warm and wet, while in the latter half of the mature Harappan phase, climatic disturbance started becoming evident at larger scales.
So, like the other ancient civilization, Indus civilization also faced downfall due to the environmental changes. There was a sudden reduction in the solar output and the appearance of modern El Nino type conditions that weakened the global monsoon system. There was a sudden decline in the precipitation in the western parts of India and Himalaya. Lakes started drying. When the winter precipitation declined, they shifted the agriculture crops to drought-resistant varieties. However, great part of the Mohenjo-daro and granary were abandoned in the beginning of the second millennium BCE. This might have been caused due to the decrease in the summer monsoon, which affected the water availability for irrigation. Hence, agricultural growth was adversely affected.
To conclude our podcast, the inhabitants were unable to develop a canal irrigation system. They were not passive in the face of climate change, and the cities of this civilization did not simply disappear. Rather, they adapted, migrated in the region of Ganga and Yamuna rivers and adjusted into a village culture.
Our next topic takes us to the arid climate of northern Africa, focusing on the prehistoric Egyptians who thrived during the pre-dynastic era from 6000 to 3000 BC. We will explore how they persevered in the face of climate adversity.
Welcome to the podcast on how ancient civilizations adapted to the environment. I am Machko Bimdike, with me is
Alfred Bidiaku.
Our poster presentation is focused on climate challenges faced by prehistoric Egyptians and their remarkable resilience.
The prehistoric Egyptians, often referred to as the pre-dynastic Egyptians, inhabited the region that is now Egypt from approximately 6000 to 3000 BC. This period marks the time from the first human settlements in the region up to the establishment of the first dynasty of Egypt around 3100 BC. The pre-dynastic period is traditionally divided into cultural eras, each named after the location where a particular type of Egyptian settlement was first discovered. However, the transition from the pre-dynastic period to the early dynastic period is somewhat blurred due to gradual development of Egyptian societies during this time.
Long before the pyramids, the prehistoric Egyptian faced a world of climate unpredictability. The Nile River, essential for their survival, could mean prosperity in one season
and disaster in the next. How did they manage to thrive in such an environment? The prehistoric Egyptians faced these environmental challenges primarily due to the unpredictable nature of the Nile River water levels. The river annual flooding was essential for depositing fertile silt onto the land, supporting agriculture. However, the timing and intensity of this flood varied greatly, leading to the period of both excessive flooding and prolonged droughts. These fluctuations in water availability pose severe threat to food security and the overall sustainability of settlement along the Nile. The ancient Egyptian civilization was also described as a hydraulic civilization mainly because of the Nile River.
The Nile's seasonal floods were both a blessing and a curse. When the floods were just right, the land was fertile, but extreme and insufficient floods led to poor harvests. To adapt, Egyptians built long-term grain storage facilities, ensuring food reserves during the hard times.
They also developed advanced agricultural techniques, cultivating drought-resistant crops like barley and emmer wheat. These crops thrived even when water levels were low. As the climate shifted and the landscape turned into the arid desert we know today, Egyptians relocated closer to the Nile Valley, where water was more reliable. This migration led to the formation of centralized government to manage resources and food distribution.
Trade became essential. Egyptians established networks to import resources not available locally, ensuring they had the necessary materials to adapt to their environment. Architectural innovation was another key strategy used by prehistoric Egyptians. They designed homes and structures to withstand harsh climatic conditions, providing stability and protection. Despite these efforts, they faced constant challenges like political instability and economic disparity, yet their resilience shone through.
To conclude, the story of the prehistoric Egyptian reminds us of human resilience in the face of climate adversity. Their ability to adapt through innovations, migration, and social organization demonstrated that with ingenuity and cooperation, societies can thrive even under harsh conditions.
In the next podcast, we will travel to the central coast of Peru, where the Corral civilization, the oldest known civilization in the Americas, was thriving between 3,800 and 1,600 years BC. We will try to find out if climate change could be a driver for their sudden disappearance.
Welcome to our podcast. Today we will travel to the central coast of Peru to explore the enigmatic rise and fall of the Corral civilization, the oldest one in the Americas. Life in Corral was strongly connected to the climate phenomenon called El Niño. Was it just a coincidence that civilization began with the arrival of El Niño on the coast of Peru and disappeared with the sudden increase in its frequency? Join us to uncover this part of history.
Picture this. It is around 3,800 years before Christ. The Corral civilization is just beginning to take root in the Supe Valley in Peru. El Niño creates mild climate, bringing warmer conditions and more precipitation. People have an effective cooperative economic system. Some of them forage fish and mollusks from the coast, while others harvest vegetables and cotton in the valley.
The Supe Valley is bustling with activity. Builders work on impressive pyramidal temples dedicated to their gods and culture.
But around 1,600 years before Christ, something dramatic happens. Corral people abandon their valley and temples and never come back. What could have driven such a prosperous civilization to disappearance?
To understand this, we must look back even further. Corral civilization appeared while El Niño was coming back after a 3,000 years hiatus. For a while, it was stable and comfortable conditions for the civilization to prosper, until El Niño started to come to the coast more and more often, around 1,800 years before Christ. El Niño brought severe floods, which transferred sediments from the valley to ocean currents and created several extensive beach reaches. The biggest one, Medio Mundo, transformed the landscape drastically. Once fertile agricultural lands of the Supe Valley turned into sand flats and swamps. Bays, used for fishing and gathering shellfish, were sealed off with sand. The lifeblood of the coral civilization was compromised.
By 1600 before Christ, due to the catastrophic El Niño events, Coral's agriculture fails and marine resources are no longer available. Coral civilization is forced to abandon their valley. They leave behind their grand temples, their homes, their entire way of life.
What happened after they left? Did they migrate to other regions? Did they assimilate with other cultures? Or did they perish? These questions remain unanswered, hidden in the mists of history. What we know for sure is that climate change happened to be the main reason for corals' disappearance.
Our next case study brings us to the Mediterranean around 500 AD. Was climate change the main cause for the decline of the Roman Empire, or were other factors deciding its fate?
Welcome, fellow students and history enthusiasts, to our latest podcast episode. I'm your first host, Ida.
And I'm your second host, Uwe.
Uwe, did you already think about the Roman Empire today?
Funny you should ask, because indeed, today, we are diving into a fascinating and often debated topic. Did climate change contribute to the decline of the Roman Empire?
Interesting idea, Uwe. The Roman Empire's decline has been attributed to many factors, from political instability to military defeats. But recently, scholars have been exploring the impact of climate change on this historic downfall.
Let's start with the climate of the Roman Empire. From around 100 BCE to 150 CE, the Mediterranean experienced what we call the Roman climate optimum. This period was characterized by warm, humid and stable conditions, which were ideal for agriculture and economic growth.
Exactly, but from 150 CE onwards, the climate in the Western Roman Empire became colder, drier and generally more unstable. This shift likely led to more frequent failed harvests and food shortages, contributing to economic and societal stress, for example to the crisis of the 3rd century CE.
The reconstructed climate data supports this. For example, reconstructed temperature data from stalactites in Spannagel Cave, which is located in Tyrol, Austria, show significant fluctuations during this period. Also, dendrochronological data from oak tree rings from Germany and France indicate changes in precipitation patterns.
Interesting, but this sounds like climate could have been the main driver in the decline of the empire, right? In my opinion, it's also important to note that the impact of climate change was not uniform across the whole empire, and other factors, such as economic stability, played an important role as well. The Western Roman Empire, which had fewer cities and was heavily dependent on local elites and the presence of legions for economic stability and growth, was more vulnerable to these climate changes.
Yes, you're correct in that assumption. In contrast to the western half, the Eastern Roman Empire, with its larger, more resilient cities and robust trade networks, managed to buffer against these climatic stresses better. This resilience helped it maintain stability longer than its western counterpart.
So, those trade networks and markets helped to distribute food from other parts of the empire if you had a local failed harvest?
Yes, exactly. And those trading routes in the west fell apart when legions in western provinces, such as Gaul, were more locally recruited and didn't come from the Mediterranean regions anymore. The western trade routes were not as old and established as those in the east.
Wow! Also, regional case studies illustrate these differences vividly. For example, in Sicily, the climate remained humid from 450 to 750 CE, supporting intensive land use and high settlement density. Meanwhile, regions like Syria and Anatolia experienced drier conditions but adapted through irrigation and agricultural intensification.
Yes, and that's why some scholars, like Paul Erdkamp, argue that attributing the decline solely to climate change oversimplifies the issue. Erdkamp emphasizes the adaptability of Roman agriculture and the importance of societal factors such as political resilience.
What do you mean by political resilience?
For example, the role of the local elites, the rich people, so to say. In the earlier days of Rome, they helped to bring down food prices for the poor when there were bad harvests, to boost their image and to help with their own political careers. And that likely wasn't the case later on, and people in the West, they depended on this disaster relief. Erdkamp's critique also reminds us to consider the broader context and the interplay between environmental and societal factors. History is rarely driven by a single cause.
He's so right. So, to conclude, did climate change cause the decline of the Roman Empire? It's safe to say climate change was certainly a significant factor, but it worked in conjunction with other elements, including economic and demographic shifts, political instability, and external pressures like invasions. The story of Rome's fall is a testament to the complexity of history.
And with that, we wrap up today's podcast. Thanks for tuning in.
And don't forget to stay curious!
The next topic takes us to the Four Corners region of the United States, where the ancestral Puebloans lived from 750 to 1300 CE.
Hello and welcome everyone! Today we're excited to introduce you to the ancestral Puebloans, a civilization that lived in the Four Corners region of the present-day United States of America. That's where Utah, Colorado, New Mexico, and Arizona meet, and they lived there from 750 to 1300 CE. This dry and deserty area has been occupied for centuries, with the first people arriving as early as 7000 BCE.
You're right, ancestral Puebloans were known for their pottery style and their iconic buildings. These structures were large, tall, and made of stone and wood. In fact, they were the tallest buildings in North America until the Chicago skyscrapers of 1880.
Yeah, that's crazy. But despite being geographically spread out, they were very organized, centering around religious hubs. They farmed maize, making up 80% of their diet. They were quite resourceful, storing food for up to 2 years due to weather, unpredictable rainfall, and crop failures. Estimates of their population are hard to come by, but some sources suggest potentially tens of thousands of people.
When you hear about tens of thousands of people living in these impressive structures and sustaining themselves agriculturally, it sounds like a thriving civilization, doesn't it? Yet, by 1300 CE, they had abandoned every last settlement. This mysterious disappearance has intrigued researchers for years, and today we will unpack some of the theories.
Alright, let's start with our first theory, which is climate change. Not human-induced climate change like we're used to hearing about today, but natural climatic oscillations like the Pacific Decadal Oscillation, or PDO. This system switches between a positive and a negative phase every 50 to 60 years. During the positive phase, the region experienced extended wet periods, which led to population growth. But when the PDO shifted to a negative phase, drought hit. The theory is that the population couldn't sustain itself during those dry periods.
Well, some argue that the Puebloans were adapted to dry climates and wouldn't have been devastated by a drought. However, most research points to drought being a significant factor. The next theory we explored was one of the most debated in the scientific community: human-induced environmental degradation. The Puebloans built multi-story houses using large quantities of wood, leading to deforestation. This deforestation caused soil erosion and increased evaporation losses, leading to increased dryness. There's also the theory that irrigation ditches lowered the groundwater table, making it almost impossible to irrigate fields.
That's crazy, right? Another theory links their migration to potential astronomical events. Around the time of the migration, a total solar eclipse occurred, which might have been interpreted as a divine warning sign driving the migration. It would also need to be considered that the Puebloan society was complex and interdependent, possibly needing a minimum population to maintain its structure. If the population had decreased due to drought or other factors, it might not have been large enough to continue in the same way as before, prompting a move. We also need to consider conflicts over spiritual beliefs.
When we look at the theme of our conference, adapt, move, or perish, the ancestral Puebloans experienced all three. They adapted by storing food and aggregating their settlements. Evidence shows their population declined due to drought and resource conflicts. Some integrated into societies further south with better climates, while others may have moved northeast, fully integrating into new communities.
Well, let's sum it all up. The ancestral Puebloans faced many challenges and responded in various ways. However, we still don't know for sure what really happened. More research is needed to understand their migration fully. Were all of the factors we discussed involved, or maybe just a few? Bringing different perspectives to the table into this research is crucial to understanding the full picture.
Absolutely. Thank you all for joining us today. We hope you found this discussion on the ancestral Puebloans as fascinating as we did.
For our next topic, we'll move to the biggest ice-covered island of the Northern Hemisphere. We will talk about the medieval Norse society in Greenland and shed light on the reasons for their disappearance in the 15th century.
Hello and welcome to our podcast episode about the Norse society in medieval Greenland. We are
Alina
and Lars, and together with you we wanted to find an answer to the question, did climate change kill the Norse in Greenland?
Many assume this to be the reason for the end of this society, but maybe we should first talk about who the Norse were, give you some historical and climatic background for context, and then discuss reasons for their disappearance.
Right, the Norse populated large areas in the Northern Atlantic, from the Norwegian coast over parts of Scotland to Iceland. In the late 10th century, around 980 AD, they also moved to southern Greenland. Two major settlements were formed, a bigger eastern settlement and a smaller western settlement. These settlements endured several centuries. The western one was abandoned at the end of the 14th century, while the bigger eastern settlement lasted about 1 century longer.
To the climatic context, we can say that this period was at the beginning of the Little Ice Age. The climatic conditions for settlement were better at the start of the Norse period in Greenland than at its end. At first, the climate was relatively mild, but the mean annual temperature slowly decreased until the 14th century, followed by a prolonged cold period from the mid-14th to the 15th century, where our society came to an end.
There are many problems associated with such a change in climate, for example increased sea ice and shortened growing periods. This negatively impacted hunting, shipping and agricultural productivity, which threatened subsistence. The Norse economy relied on hunting, fishing and products of domesticated animals. These climatic changes negatively affected trading and economic progress. Furthermore, trade relationships with Europe diminished over the settlement period, likely because of the European commercial revolution and the ivory competition from Africa.
Moreover, the Norse did adapt to these climatic changes. For example, the condition of livestock was closely monitored. When the weight of livestock decreased, the number of animals on a pasture was reduced to avoid overuse and degradation. Additionally, they switched from a mainly terrestrial diet to a marine one, in order to compensate for a decreasing amount of terrestrial food sources. Some of the measures they took were more successful than others, but ultimately they were all futile due to the continuously worsening conditions.
Another factor that could have contributed to the disappearance of the Norse was the approach of the Thule, who expanded along the western coast of Greenland during the 14th century. They settled in Norse hunting grounds and along Norse sailing routes, which could have possibly led to conflicts. Today's Greenlanders are descendants of the Thule. There is no genetic evidence of the Norse.
To put this podcast episode in a nutshell, climate change did not kill the Norse in Greenland. Their society did not end abruptly. There was a gradual population decline due to slowly worsening conditions. These conditions were caused by a complex interaction of interdepending factors. Climate change was only one of them. But we are left with one question. Where did the Norse go?
Toward the Khmer Empire in Southeast Asia, where the capital city of Angkor prospered between the 9th and 15th century. Several challenges led to instability and the final fall of the empire. The question remains, could the Khmer survive the fall of their empire?
When we think of the former advanced civilizations in Southeast Asia, one of the most impressive abundant city complexes in the world springs to mind. Angkor, the former capital of the ancient Khmer Empire. The empire existed from the 9th century until its decline in the 15th century. However, the population and agricultural activities increased very quickly, particularly between 950 AD and 1300 AD, due to the medieval climate anomaly and the resulting high rainfall. But what happened to this advanced civilization? Although the city of Angkor was highly developed, with its hydraulic system and adapted to the climatic conditions, the inhabitants had to contend with numerous problems of various kinds in the 14th and 15th century. Tree ring analysis show that there were a number of extreme climatic conditions. There have been alternating severe droughts and equally intense monsoon events, to which the approximately 1,000 square kilometer large canal system could no longer be adapted despite intensive efforts. In addition, the Khmer Empire was involved in military conflicts with its neighbors, particularly the Kingdom of Siam. This further weakened the Khmer Empire. Another important aspect was disease. On the one hand, the jungles of Southeast Asia are an ideal incubator for deadly toxins, poisons, and diseases such as malaria. On the other hand, the plague probably came to anchor around 1250 AD and also led to a severe burden and reduction of the population. To make matters worse, major political and cultural changes further destabilized the empire. For example, the dominant religion changed from Hinduism to Buddhism. In addition, agriculture lost importance during this period and trade has become more relevant. As a result of all these factors, Angkor fell as the capital of the Khmer Empire in 1431 AD, and the political center was moved to what is now Phnom Penh, and the city was almost completely abandoned. But does the Khmer civilization still exist? Yes. Today the Khmer are the largest ethnic group in Cambodia, with over 15.5 million people. So, their history lives on.
Next, we will talk about the rise and fall of the classic Maya and how climate influenced their history.
Hello and welcome. I'm Robin and with me is Morten. We're both students of the Landscape Ecology Master Program at the University of Greifswald, getting ready for the upcoming climate change conference here at the university. Today we will talk about the fascinating history of the classic Maya and how climatic and societal developments influenced their civilization. Hello, Morten.
Hi, Robin. I'm excited about our discussion, especially since we will be attending the conference where we will be presenting some amazing research on this topic. The classic Maya are incredibly fascinating.
Absolutely. So, a quick overview. The classic Maya civilization thrived between 250 AD and 950 AD in what is now southeastern Mexico, Guatemala, Belize, Honduras, and El Salvador. They were renowned for their sophisticated writing system, monumental architecture, and advanced knowledge in astronomy and mathematics.
It's interesting how climate played a crucial role in their society. Initially, favorable climate conditions supported agricultural advances and population growth, all factors leading to a complex city-states.
Yes, climatic factors were beneficial for the rise of the Maya. But the demographic changes, which led to the end of the classic Maya period, were also likely linked to the changes of climatic conditions.
That's true. Our poster at the conference highlights the climate change hypothesis, which is a widely accepted theory explaining the social changes. As warfare intensified and deforestation increased, soil degradation worsened, exacerbated by several droughts, leading to the abandonment of major cities.
This led to the migration from the southern lowlands to the northern lowlands, marking the start of the post-classic Maya period around 950 AD. And this actually raises the question, was this truly a collapse or an impressive adaptation to changing conditions?
That's a key point of our conference. It's important to move beyond the classical European perspective and appreciate how the Maya adapted to their environment.
This conference is a great opportunity to explore these topics from various angles and gain deeper insights. We hope many of you will join us to learn more and participate in the discussions.
We look forward to see you there. Until then, stay curious and open to new perspectives.
For the next topic, we have to fly more than 6,000 kilometers to the southeast in the middle of the Pacific, to a society whose tribulations started a few decades later, the Rapa Nui on the Easter Islands.
It's around 1200 AD. A small group of Polynesians takes their canoes eastward, not knowing what they'll find. After weeks on the water, they set foot on a small island in the middle of the Pacific, unaware that they have found one of the most remote places on Earth. It's a small volcanic island covered in palm forests. They call their new home Rapa Nui. Nowadays, it's famous as Easter Island. Over the next centuries, they built a thriving society of about 3,000 people. Despite the difficulties a volcanic island poses, they practiced sustainable agriculture. They erected moai, the famous statues of giant heads we associate with Rapa Nui today. Now all that's left of the society is the hundreds of statues they built. The disappearance of the society has fascinated many generations of scientists. But what actually happened to the Rapa Nui society?
Geological and palynological records show a shift from palm to grassland-dominated vegetation. The disappearance of the forest is proven, but what caused it and the impact it had on the Rapa Nui society is unclear. A growing population of rats that fed on palm seeds could have played a role in the deforestation of Rapa Nui. There's also evidence of deforestation by the Rapa Nui people themselves in order to clear land, for example for buildings and agriculture. Another possible factor in the deforestation of Rapa Nui are extensive droughts caused by increased La Niña events during the Little Ice Age from around 1520 to 1710. Whether this deforestation caused the demise of the Rapa Nui society is still debated, but evidence suggests that they were well adapted to the harsh conditions they lived in. But they weren't adapted to the diseases and conflict the European explorers brought with them after they first reached Rapa Nui in 1722. In the following centuries, the population of Rapa Nui declined rapidly. Tales of cannibalism in a self-destructive society told by Europeans sparked the theory of ecocide, a society destroying itself by overexploiting their resources, which led the society into chaos before the colonization of Easter Island. In recent years, this theory has been doubted more and more. Unfortunately, the only witnesses that could tell us the whole truth are made of stone. But the Moai stay silent.
Next, we look at the Canadian Arctic, where climate change is dramatically altering the landscape and impacting Inuit communities. We'll discuss how rising temperatures are reshaping their traditional way of life and what measures are being taken to adapt to these changes.
Hello, welcome everybody. Today we want to explore how climate change is reshaping life in the Canadian Arctic, particularly for the Inuit communities. I'm Linda, your host for today, and together with Luke, an Arctic climate scientist, we want to understand these changes. Welcome, Luke.
Thank you, Linda. It's a pleasure to be here.
To understand the Canadian Arctic's unique vulnerability to climate change, we need to look at the numbers. The region is warming twice as fast as the global average, leading to dramatic changes. Climate models show that the climate change will be amplified in Arctic regions, with the greatest increase occurring during wintertime. Luke, how serious is the warming effect and what does it mean for the region?
Sure, Linda. The warming in the Arctic leads to significant ice melt and reduces ice thickness, which alters sea ice dynamics. Permafrost thaw in the Arctic can lead to slumps and landslides, which significantly contribute to coastal erosion. This process can result in the mobilization of large amounts of sediment entering nearby streams and rivers. Highly variable seasonal precipitation and more extreme events, such as intense snow and rain, are more likely to occur. It can be said that temperature is the most critical factor for Arctic ecosystems.
Alright, so the Arctic is transforming extremely fast, with extreme challenging environmental conditions caused by this rapid warming trend. How is this affecting the life of the Inuit?
More frequent extreme weather events and changing sea ice dynamics are disrupting traditional hunting and fishing, making some areas unsafe for these activities. For example, increasing rain on snow events also affect caribou grazing, as they must break through ice to access their food. Also, changes in precipitation over the growing season can affect the availability of certain plants and other food sources.
It's clear that these changes have a profound impact due to the Inuits' close relationship with the environment. How are they coping with these disruptions? Are they implementing any adaptation strategies, or are they receiving support from external sources?
The Inuit are indeed highly vulnerable to these environmental changes. They have been employing various strategies to cope with these disruptions. These strategies include altering hunting practices, such as shifting the timing and location of hunts to safer areas, and using new technologies, such as GPS and weather forecasting tools, to improve safety and efficiency. As certain species become harder to harvest due to changing ice conditions and weather patterns, the Inuit have had to adapt their diets. For example, they shift from primarily hunting seals to species that are easier to access, such as fish or caribou.
Okay, so this affects not only their diet, but also their cultural practices?
Absolutely, it's deeply intertwined with cultural identity and traditional knowledge. There are community-led initiatives focusing on preserving traditional knowledge and practices, which are crucial for adapting to these changes. The collaboration between Inuit communities and government agencies or international organizations is necessary to ensure a sustainable development.
Meaning they are already receiving support from external sources, but are all of those adaptive strategies and the additional external help enough?
While these adaptive measures are crucial, they are not always sufficient, given the rapid pace of climate change. The community's adaptive capacity is also constrained by socioeconomic factors, such as limited financial resources, inadequate infrastructure, and restricted access to healthcare and education. External support is therefore vital. This includes governmental assistance, infrastructure development, and programs aimed at strengthening local capacity and resilience.
Alright, thanks Luke. Let's wrap up by summarizing the key points we covered today. So the Inuit are facing significant challenges due to climate change, affecting their traditional way of life and cultural practices. While they are employing adaptation strategies, external support is essential to address socioeconomic constraints they face. Thank you for joining us, and I wish all of you a wonderful day.
And finally, I will wrap this up myself with an almost literally burning question. Are we ready for climate change? Let me give you an overview of what the world has planned. Climate impacts are getting more and more noticeable everywhere, with droughts, flooding, and heat waves across the world. Countries have long made promises to prevent the climate crisis. Agreements got signed, promises made, but the gap between the targets and reality keeps widening. With climate change no longer a thing of the future, but our present reality, the burning question remains. Are we ready for climate change? In 1992, so quite a while ago, 197 countries signed the first global agreement to address climate change. The parties meet regularly to discuss how to proceed. The most notable agreements include the Kyoto Protocol and the more recent Paris Agreement. The Paris Agreement set targets to keep global temperature rise below 1.5 degrees, if possible, that is, and below 2 degrees if that isn't an option. But the status is not quo. The parties knew that the goals they originally set were not enough. So part of the deal was to update their plans by 2020. In 2021, the parties met again, but realized they'd fall short again. So they pushed the deadline to 2022. By now, most countries have submitted net zero plans, but the plans remain vague and inadequate, according to the Climate Action Tracker. While both planning and actual implementation have continued across the board, which is really good news, there is a gap between needed adaptation and current reality. According to the Adaptation Gap Report by the UN Environmental Programme, aptly named Too Little, Too Slow, we are on the verge of an energy, food, and water security crisis. Wars, heat waves, and floods impacting supply, the COVID-19 pandemic, there are many reasons why the gap keeps widening. But to quote the same report, adaptation must not be sidelined because of large-scale, non-climate, and compounding factors. In other words, no matter how much other nonsense is happening all around the world, we need to deal with this now. It cannot be delayed. So are we ready? My personal opinion is we could be. We have everything we need to be ready. We're just lacking the collective will to make some tough choices. We need tighter climate targets, and then we need to follow them. Now.